Good morning, all. This is Mrs. Arshika, working as Assistant Professor in AA and DS Department, subject code AL3451, subject name Machine Learning in Regulation 2021. There are two types of supervised learning, regression and classification. Today we are going to discuss the topic as a classification. Classification is a supervised learning technique where the goal is to predict labels or categorize based on input data, to assign data points to a predefined classes. Key types: binary classification and multi-class classification. In binary classification, it categorized into two types. One is category 1 and another one is category 2. In multi-class classification, it classifies into three categories, etc. Some of the example for classification is identifying email as a spam versus non-spam, or diagnosis a patients as diseases versus healthy. Types of regression. Logistic regression. It is a binary supervised machine learning algorithm used for classification problem, especially when the output is categorical. Binary focuses, it is primarily used for binary outcome such as yes, no, 0 or 1, pass, fail, spam or not spam emails. Comes to practical examples of categorical prediction. Email filtering, predicting if a mail is spam, yes or no. Admission, determining if a student should be admitted based on entrance exam marks, admitted or not admitted. Academic success, predicting if a student passes or fail based on the marks secured. There are two types of regression. One is linear regression and another one is logistic regression. In linear regression, it fits a straight line where the predicted value y can exceed the 0 to 1 range. In logistic regression, fits an S curve, that is sigmoid function, where the predicted value is straightly bounded between 0 and 1. In logistic regression, use the sigmoid function to predict a categorical dependent variable. The S curve maps any real valued number into a value between 0 and 1, making it ideal for probability. Threshold value is always 0.5. It used to decide the classes. Above threshold y equal to 0.3 is below. Logistic regression algorithm uses a 50% probability threshold to classify outcome: success, zero point 0.5 success and zero point 0.5 failures. If probability less than 0.5, failure occurs. Probability greater than 0.5, success occurs. And another example, performance and salary hike. An organization predict an employee's salary hike based on their performance rating 1 to 5. While a linear regression could show the trends of hikes, logistic regression would be neat if the outcome was categorical, yes or no. These are the steps involved in logistic regression. Linear combination, calculate the linear formula z equal to b naught plus b1 into x. Applied sigmoid, pass the linear result through the sigmoid function. Probability conversion. Convert the function output into a probability score. Next, classification. Use the threshold value 0.5, it's usual, to assign a final class. Mathematical foundation sigmoid equation. Sigmoid function. Sigmoid z equal to 1 by 1 plus e power minus z, where z equal to b naught plus b1 into x, it's for univariant. In case of multivariant, use z equal to b naught plus b1 x1 plus b2 x2 plus etc plus bn xn, where z is the linear combination of input. Output probability between 0 and 1. We can apply decision rule. If y equal to probability of y equal to 1 given x greater than or equal to 0.5, predict class 1. If probability of y equal to 1 given x less than 0.5, predict class 0. Usually the threshold value is 0.5. Here an example. If a person would buy life insurance based on his age using logistic regression and importing the library file pandas and matplotlib and read the insurance data CSV file and list the output. Features are age and rot insurance. By using the plot scatter, we can plot the point as a plus, mark as a plus and color equal to red. Based upon the x and y values, the plotting can be appeared. Thank you.